This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today, let's learn how to identify properties of sine and cosine functions, known collectively as sinusoids. We'll start by focusing on three properties we can determine by looking at their graphs. The first property is the vertical shift. You can find the vertical shift by identifying the midline of the sinusoid or its average value. In this case, 3. The amplitude is the distance from that midline to an extremum, either a maximum or a minimum. In this case, 1. You can also calculate it by finding the difference between the maximum and minimum values and dividing by 2. A third property we'll look at is the period. This is the horizontal distance from peak to peak or from trough to trough. In this case, 2 pi. In other words, it measures how long it takes the function to repeat a full cycle. Let's learn more through some examples. Here we're given a graph and asked to find three properties. To find our vertical shift, let's identify the midline of our function. It looks like it's at 2, but to be certain, let's find the average of the maximum and minimum values. It looks like our maximum is 5 and the minimum is -1. So their average is indeed 2. Our vertical shift is 2. Next, we can find our amplitude by measuring the distance from this midline to a maximum or minimum. It looks like 3, but let's check by finding half the difference between our maximum and minimum, which equals 3. Sure enough, the amplitude is 3. Last on our list is the period. We could use the distance between consecutive maxima, but since those points don't match up with tick marks on our x-axis, let's use the minima. It looks like the distance is 3 pi, and sure enough, if we find the difference between those x values, we can be confident that our period is 3 pi. Great work! Let's try another together. Here's another sinusoidal graph. We want to know the same three properties as last time in addition to the frequency, which is just the reciprocal of the period. Starting with the vertical shift, we can take the average between the maximum value of 3 and the minimum value of -5, which is -1. Drawing a midline of y equals -1 on the graph does seem to cut it perfectly in half. The difference between this midline of -1 and our minimum of -5 is a distance of 4, which is the same distance from our midline to our maximum of 3. Either way, this tells us that our amplitude is 4. To find our period, we should determine how often our graph is cycling between maxima. I notice that it completes 3 full cycles from 0 to pi, meaning that it completes 1 full cycle in a third of pi. So we could say our period is pi over 3. Lastly, to find the frequency, all we do is take the reciprocal of the period. So it becomes 3 over pi. Now that we've seen some sinusoidal graphs, let's learn how to identify these same features and more when given an equation. This is a standard equation for a sine function, and the same patterns will apply to cosine functions. To find our amplitude, we just take the absolute value of a, the number multiplying our sine or cosine. To find our period, we start with 2 pi, the natural period of both sine and cosine, and divide by the absolute value of b. As we saw before, the frequency is just the reciprocal of our period, which could also be written as the absolute value of b over 2 pi. Another property of sinusoids is the phase shift, which represents a horizontal shift, left or right. The phase shift is represented in the equation by the parameter c, the number subtracting from x. Lastly, the vertical shift is represented by d, the number added or subtracted outside of the sine or cosine function. Let's practice finding these values for specific functions. We'll start by finding the phase shift and vertical shift for the function g of x. This means we need to identify the c and d parameters in our function. But first, do you notice how g of x doesn't quite match the structure of our general equation? For example, the x has a coefficient of 3 that we need to factor out. When we factor 3 out from both terms inside of the sine, its argument becomes 3 times the quantity x plus 2 pi. I also notice that in our general form, c is being subtracted from x rather than added. So let's rewrite the addition of 2 pi as a subtraction of negative 2 pi. Now that g of x matches the general equation, we can identify c as negative 2 pi and d as negative 5. This means that there is a phase shift of negative 2 pi, or 2 pi to the left, and that there is a vertical shift of negative 5, meaning our graph shifts down by 5. Nice work! Let's try one more equation. This time we're asked to find the amplitude, period, and frequency, which means we need to identify the a and b parameters in our equation. Also, remember that even though this is a cosine function, the pattern is the same as for sine. First, let's rewrite our function to match the general form by factoring out negative 2 from the terms inside cosine. Now we can more clearly see that the value of a is 1/3 and the value of b is negative 2. To find our amplitude, we'll calculate the absolute value of a, which is simply 1/3. To find our period, we divide 2 pi by the absolute value of b, which simplifies to pi. Our frequency will be 1/pi, since it is the reciprocal of the period. Nice work identifying these key features of sinusoids. Keep practicing and improving your skills.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.